How does blue light affect a student's ability to sleep? In a study conducted by the CDC, students were asked how much sleep they usually got on school nights. Children ages 6 through 12 need at least 9 hours of sleep, and teenagers ages 13 through 18 need at least 8 hours of sleep. The data shows that 57.8% of middle school students and 72.7% of high school students did not get enough sleep on school nights. The data in the previous slide shows that there is a consistent problem with children not getting enough sleep. Some of the health risks associated with lack of sleep include attention and behavior problems, as well as poor academic performance. As seen in Table 2, a majority of high school students are getting an insufficient amount of sleep. Getting consistent sleep is vital for children and adolescents who are experiencing significant brain development. When students don't get enough sleep, they experience decreased attention, impaired memory, and slowed processing. Many students struggle with early tests and classes because of decreased sleep, which in turn hurts them academically.
Circadian rhythms are your internally driven cycles that rise and fall during the 24-hour day and also regulate when you fall asleep and wake up. Zeitgebers, or time giver in English, reset your circadian rhythm. Examples of Zeitgebers include light, artificial and natural, and temperature, light exposure being the most important. The suprachiasmatic nucleus is a structure in the hypothalamus and is the pacemaker of the circadian timing system and regulates most circadian rhythms in the body. Light is connected to the SCN through photosensitive ganglion cells in the retina. Photic impulses cause the SCN to signal the pineal gland. The pineal gland synthesizes melatonin for sleep.
Melatonin is a hormone produced in the pineal gland. Its secretion is positively correlated with exposure to darkness, and it helps you fall asleep at nighttime. It is also a key factor in the regulation of the 24-hour circadian rhythm. If you are exposed to light once it is nighttime, the pineal gland will not secrete as much melatonin, making it harder for you to fall asleep and offsetting your circadian rhythm. Since we know light is a Zeitgeber and students spend a majority of their day in school, we attempted to find research to discover whether the artificial lighting in schools could possibly affect students' sleep schedules. A study examined the effect of optimized dynamic lighting and electric lighting on the circadian phase of melatonin onset and the skin temperature of healthy young office workers. Researchers placed workers into two different rooms with two different light systems. The test room, which with optimized natural lighting, and the reference room with electric lighting of a common office room. 34 workers spent 5 days in each of the different rooms working from 8 to 6 p.m. each day. Then each worker's individual light exposures, skin temperatures, and saliva samples were assessed for melatonin and cortisol. To create each of the different light settings, these researchers used photopic lux to quantify the type of light. Photopic lux is a measure that describes an average response of the three color vision receptors or cones. The optimized dynamic lighting was set at 858 plus or minus 478 photopic lux, while the electric lighting was set at 1177 plus or minus 562 photopic lux. Figure 4a summarizes major results with regards to melatonin secretion onset. The box plots for the average melatonin secretion onset in participants over a period of 2 days per condition, aligned to the elapsed time since habitual mid-sleep, for both conditions are shown. The corresponding clock time is shown on the upper x-axis, while the time from the mid-sleep is shown on the bottom x-axis. This graph shows that the average melatonin onset occurred significantly earlier in the test room than in the reference room, and that also participants in the reference room slept for a shorter period of time than the participants in the test room. This data helps to confirm the hypothesis since the office workers in the optimized daylight setting did have an earlier melatonin onset than the workers who were placed in the electric light. Since melatonin is an essential hormone in maintaining the body's circadian rhythm and sleep cycle, these results are significant because they show that the type of light used does significantly affect the onset of melatonin and this person's ability to sleep. Much like office workers, students in schools spend a majority of their days being exposed to harsh electric lighting in their buildings.
Modern devices are becoming increasingly reliant on LED displays. These diodes give off white light, which contains all wavelengths of visible light. The most important is blue light. Since it carries the most energy, around 3.1 electron volts on the highest end, it has a greater effect on photoreceptors in the eyes. Due to the larger effect on the photoreceptors in the eyes, the SCN is also affected more heavily. This effect on the SCN causes it to act as if the organisms were still in an active state. This includes being more alert during later hours of the day when exposed to blue light in the evening. In a study created to test the effect of blue light on different organisms, male mice were exposed to periods of blue light enriched white light and blue cut white light before their sleep cycle began. This in turn causes a shift in their biological clock shown through the difference in the length of the arrows in the graphs to the right. These graphs show the activity of the mice as green lines and inactivity as white space. The difference in the arrow length proves that blue light has a greater effect on the SCN and has a similar effect on the body's biological clock as a result. The longer line corresponds to the blue enriched white light, which contains the high energy blue light. The shorter line is represented by white light that has had the blue wavelengths filtered out. So, higher energy visible light causes a greater shift in the biological clock of mice. Because almost all organisms share a suprachiasmatic nucleus that carries out the work of a biological clock, the result of the study on mice can be generalized to humans. So it is likely that humans who experience light closer to their sleep cycle in the evening wake later and then fall asleep later the next day. They will be less rested for school in the morning.
Dynamic light and electric light have different effects on melatonin secretion. If schools replace electric lighting at 1,177 plus or minus 562 photopic lux with optimized dynamic lighting at 858 plus or minus 478 photopic lux, it will optimize the biological light effects and prevent a phase delay in the circadian rhythm because of reduced blue light exposure. In addition, deadlines at midnight cause students to be up late working on their computer. Therefore, students are exposed to blue light before they go to bed. Earlier, mid-morning, afternoon deadlines could help students get a better night's sleep by not being up on their computer until midnight to submit an assignment. The solution does not account for the type of light exposure students experience at home outside of school. It does also not account for the expense of installing lights that mimic natural biological light in classrooms with no windows.